Hello friends, welcome back to Secret of Electronics. In today's video, we are going to build a simple yet stylish digital clock with alarm functionality using a 4-digit 7-segment display and 8Mega328P microcontroller and a DS3231 RTC module. This project not only looks great but it also very easy to make, perfect for beginners and hobbyists. So make sure to watch the video till the end to see how it all works. This circuit diagram represents a digital clock with alarm functionality built around the 8Mega328P microcontroller. The main components include a 4-digit common cathode 7-segment display, a DS3231 RTC module, and 3 push buttons for setting the time and alarm. The 7-segment display is directly driven by the Atmega328P digital pins D2 to D9 for segment control and D10 to D13 for digit selection, with each segment line protected by a 220 ohm current limiting resistor. The DS3231 real-time clock module connects to the microcontroller by the I2C interface using pins A for STA and A5 for SCL, ensuring precise timekeeping. 3 push buttons connected to A0, A1 and A2 allow you to set the hours, minutes and alarm time, with 10 kilo ohm pull-up resistors providing stable input signals. A buzzer attached to pin A3 sounds the alarm when the preset time is reached. The 8Mega328P runs on a 16 MHz crystal oscillator paired with two 220 picofarad capacitors for stable operation. The entire circuit is powered by a 5-volt DC supply, which efficiently powers the microcontroller, display and RTC module. This setup makes it easy to build a sleek, fully functional digital clock with alarm capabilities. At the top, we include 3 essential libraries: wire for I2C communication, RTC leaf for working with the DS3231 real-time clock, EEPROM to save our alarm time so it remembers even after power off. Then we create an RTC_DS3231 object called RTC to interact with the RTC module. Next we define all the pins. Buzzer pin controls the alarm sound. 3 buttons, hour button, minute button and mode button, help us set the time and alarm. DP pin for the decimal point of the display. Arrays, segment pins and digit pins define connections to the 7-segment display, segments and digits. We use volatile booleans to track button presses so we can respond instantly using interrupts. We also have variables for beep timing, hourly beep detection, alarm mode, and 1 second on and off alarm pattern. Finally, we define the segment patterns for numbers 0 to 9. This is how the microcontroller knows which LEDs to turn on for each digit. To make the alarm memory persistent, we have save alarm to EEPROM to save the alarm hour and minute. Load alarm from EEPROM to read them back when the clock powers on. This ensures your alarm time is not lost if the microcontroller loses power. Inside setup function, we start I2C communication with wire.begin and initialize the RTC, configure all pins as input or output, turn off the buzzer and decimal point initially, load the saved alarm time from EEPROM, and finally we enable pin change interrupts for our buttons so we can detect button presses without constantly checking in the main loop. The ISR PC int 1 underscore back triggers whenever a button is pressed. B deworms the button by checking if at least 150 milliseconds have passed since the last press. Then we set the corresponding boolean hour pressed, minute pressed, or mode pressed to true. This allows us to handle button presses instantly without blocking the rest of the code. Display digit function handles showing numbers on the 7-segment display. First, it turns off all digits to avoid ghosting. If we are on the second digit, the decimal point blinks to indicate the clock is running. Then it sets each segment high or low according to the number we want to display. Finally, it enables the chosen digit for a short time using multiplexing to make all 4 digits appear light continuously. Now the heart of the clock is in loop function. Update time from RTC. We read the current time from the DS3231 every 200 milliseconds. Handle mode toggle. If mode button is pressed, we switch between normal clock mode and alarm set mode. Handle hour and minute buttons. In alarm mode, pressing the buttons changes the alarm hour or minute and saves it to EEPROM. In clock mode, pressing the buttons updates the RTC's hour or minute. Convert 24-hour to 12-hour format. For display purposes, we convert the 24-hour RTC value to 12-hour format. Hourly beep. If a new hour starts, the buzzer beeps for 1 second. Alarm trigger. When the clock reaches the set alarm time, then the alarm active becomes true. The buzzer starts a 1 second on, 1 second off pattern. The alarm stops automatically after 1 minute. Display the numbers. We prepare an array, display data with either the current time or the alarm time, depending on the mode, and call display digit for each digit to show it on the 7-segment display. With this code, you get a fully functional digital clock that can show the current time, let you set hours, minutes, and alarm, provide hourly indication, and trigger a 1-minute alarm with a pulsating buzzer sound. This setup is perfect for anyone wanting a customizable Arduino-based clock with an interactive 7-segment display. First, place the Atmega328 microcontroller onto your Arduino Uno board in the correct orientation. As you can see, I have already placed it correctly. Next, connect the Arduino Uno to your PC or laptop using a USB cable. Once connected, open the Arduino IDE, then open the code file. You can download it from the link provided in the description. Before uploading, make sure all the required libraries are installed. I have already installed them, so we will skip that step here. Now go to the Tools menu and select the correct board and port. Once everything is set, click the Upload button. After a few moments, the code will successfully upload to the Atmega328 microcontroller and your digital clock is ready to go. Now as you can see, I have also designed the PCB for this digital clock using KiCad software. I actually built this PCB at home using the etching method and have soldered all the components in place. You can download the PCB layout from the link provided in the description. At this stage, all that's left is to place the Atmega328 microcontroller onto the PCB. And don't worry, if you do not want to make the PCB, you can still build this project on a breadboard by following the main schematic we discussed at the beginning of this tutorial. Now I have connected the PCB to a 5V DC adapter, and you can see the time displayed on the 4-digit 7-segment display. We can update the time using the hour and minute buttons. To set the alarm, first press the set alarm button, then adjust the alarm time using the same hour and minute buttons that we used to set the clock time. After setting the alarm time, press the set alarm button again to save it and return to the normal clock display. Once the current time reaches the alarm time, then the alarm is triggered and the buzzer starts beeping. It will continue to beep for 1 minute. Now I am adjusting the clock time again to demonstrate the hourly indication functionality. You can see that when 1 hour is completed and the minutes reach to 0, the buzzer plays a short beep for 1 second to indicate the hour has passed. If you enjoyed this tutorial, then do not forget to subscribe to our YouTube channel to watch more interesting tutorials. And if you have any project ideas that you would like me to create and share, let me know in the comment section and I will make it for you.